Everyone, welcome to my civil engineering YouTube channel. Please subscribe to this channel and hit the bell icon to get notified when I post my new videos. So today I'll be discussing how to determine the horizontal force applied on a block. So here I have a numerical over here. So wherein we need to determine the magnitude of the horizontal force which is applied on the block, and you can just notice that the block is exactly present on the inclined plane, so which is having the angle of inclination as 30 degree. So here I repeat it. So we need to find out what is the magnitude of the horizontal force which is applied on the block, which on which the block which is present on the inclined surface whose angle of inclination is equal to 30 degree with reference to horizontal. So F is a force wherein we are supposed to find out its magnitude. So the self weight of the body, self weight of the object is given to be as 1000 newtons. So we need to find what is the horizontal force on the block at two cases. So first case is that the motion impending down the plane. So whenever the object is moving down the plane, so the case one is we need to find out what is the force which should be acting whenever the motion is down the plane. And second one is we need to find what is the magnitude of the force F acting on the body or on the object whenever the object moves up the plane. So we have the first case as the motion impending down the plane. So here you can just observe in the first sketch. So here the motion trend is in the downward direction. So the body or the object which is going in the downward direction. So this is the motion trend. So whenever the motion trend is in the downward direction, so exactly on the opposite direction there will be the frictional force. So it is given by mu into r, as we know that F by r is equal to mu. So F is explained in terms or expressed in terms of mu and r. So it is termed to be as mu into r, and exactly on the axis I have drawn the x and y axis on the plane of the object, on the plane of the object. So here, so if at all if this is equal to 30 degree, so if at all if this is equal to 30 degree, so the object which is carrying the self weight of 1000 newton, the object which is carrying the self weight of 1000 newton, it will be having the angle of inclination as equal to 60 degree, Why? Because so since this is the this angle, so this angle is equal to 30 degree. So this angle is equal to 30 degree. So we know that this is a perpendicular. So this with reference to the horizontal, it is equal to 60 degree. So it is equal to 60 degree. So next, coming on to the amount of force applied. So amount of force applied. So as we all know that with reference to the angle of inclination, what the amount of angle which is present as the angle of inclination, so same angle of inclination will be there for the force F which is applied with reference to the x-axis. So the same will be with reference to the x-axis, that is equal to 30 degree. So this is all about the angle of inclination with reference to the horizontal and vertical axis. So now coming on to the next step is that we are supposed to resolve the components of the forces. So here I have taken F is acting at an angle of 30 degree with reference to horizontal. So therefore, so if this is the resultant, so this is the x and y direction force. So if the resultant is going in the inside direction, both the components should go in the inward direction, means f sine that is the vertical component and the horizontal component should meet at the same point. So like that it should be the direction. So the horizontal axis is inclined, the force is inclined with reference to 30 degree with reference to the horizontal axis, means the horizontal component will become f cos 30 and the vertical component will become f sin 30. So f sin 30. So similarly we have resolved that. So it is f cos 30 along the horizontal direction we have and f sin 30 along the vertical direction we have. So similarly, as I said that 1000 Newton is inclined at an angle of 60 degree with reference to horizontal axis, means 1000 cos 60 will be the horizontal direction force which is acting in the left side direction, and then 1000 sin 60 is acting in the downward direction, in the vertically downward direction. So similarly in the question they have mentioned that the coefficient of friction on all the surface is taken to be as 0.25. So therefore mu times of r is equal to 0.25 times of r. So this is how we are supposed to draw the free body diagram for the given respective forces with the respective angle of inclinations. So now coming on to the next very important step is that we need to find out the force F, the magnitude. So for finding that, we are going to apply the equilibrium condition both in the horizontal as well as the vertical direction. So firstly, if I want to apply the vertical equilibrium condition, so I state that I need to consider all the forces which are acting in the vertical direction. So if I just take that into consideration for overall system, so f sine 30 is the first vertical force. Secondly we have 1000 sine 60. So and the last one we have is r. So I just considered upward force as positive and downward force as negative. So with this sign convention, if I want to proceed, sigma v, that is summation of all the vertical forces, will be equal to 0. So therefore f sine 30 with the negative direction because it is acting in the downward direction. So next is 1000 sine 60 which is again acting in the downward direction, hence it is minus, and then plus r equal to 0. Why it is plus r? Because it is acting in the upward direction. So if I just rearrange these forces, I'll get r is equal to f sine 30 plus 1000 sine 60. So this is the expression for the vertical equilibrium. So next is application of the horizontal equilibrium. So here in this case we are going to see only the horizontal forces into consideration. So if I just start as a system as a whole, so I have f cos 30 which is going in the right side direction, 1000 cos 60 going in the left side direction, and 0.25 times of r going in the right side direction. So I just take right side forces as positive and left side going forces as negative. So if I just resolve this, I just take sigma h, that is summation of all the horizontal forces, is equal to 0. So f cos 30 is going in the right side direction, it is equal to positive, and 1000 cos 60 it is going in the left side direction, it should be equal to negative, it should be negative. And then I have 0.25 r, that is nothing but f itself. F is equal to 0.25 r going in the right side direction, hence it is considered to be as negative. So and in place of r I need to substitute the value which I have obtained in the calculation of the vertical equilibrium. The equation which I have obtained is f sine 30 plus 1000 sine 60. I need to substitute in place of r. So after all simplification, I'll get the value of f as 286.07 Newton. 286.07 Newton. So this is the force acting along the direction of the object with an angle of inclination of 30 degree with reference to horizontal. So this is the force which is helpful for the object to slide down the plane. So next is second case is that we need to find out what is the amount of force which is responsible for making the object to move up the plane. So we have the all the things are same, but here we just take the motion trend to be in the upward direction. So if the motion trend is in upward direction, the frictional force will be in the downward direction, that is mu times of r is in the downward direction. So this is the free body diagram for this. So all the other things remains the same, only the direction of the motion trend as well as the frictional force will be reversed. So in this case, if I just apply the vertical equilibrium condition, sigma v equal to 0, I have f sine 30, 1000 sine 60, and r I have. So r will be equal to f sine 30 plus 1000 sine 60. So based on the respective sign convention. So next is I need to apply the same horizontal equilibrium condition. So I have f cos 30 going in the right side direction, positive. So minus 1000 cos 60, so going in the left side direction, hence it is negative. And also minus f, so here minus f is nothing but 0.25 times of r going in the left side direction, hence it is considered to be as negative. So I know that r is equal to f sine 30 plus 1000 sine 60 from the calculation of the previous slide with the help of vertical equilibrium condition. So if I just substitute the value of r in the equation, I'll get the value of f as 966.93 Newton. So this is the amount of force which is responsible for the object to impend in the upward direction of the plane. So this is how we are supposed to calculate the magnitude of the forces which in both the cases. So it is in the down the plane and which is in up the plane. So only the thing is we need to check what are the angles which are responsible firstly, and secondly we need to check for the respective motion trend. And also with the respective motion trend, always the frictional force should be in the opposite direction to that of the motion trend. Thank you for watching. Please like, share and subscribe the video. Thank you.